So I don't know how I'm going to follow that. That was intense. I'm going to be telling a story about a crisis averted. I'll talk about how CSS helped my previous employer avert that crisis. And I'm going to tell you why you should keep an open mind about your tools in your tool set. So cast your mind back to the dim, dusky days of mid-2012. I remember that everyone was getting really excited about CSS shaders at that time. Unfortunately, that doesn't seem to be such a big thing on the agenda anymore. WebGL, and especially WebRTC, was really big. It was an exciting year. I was working for a large government department, really big Australian federal government department, and we were just putting the finishing touches on a brand new website. We had this isn't it, the identity has been protected to, changed to protect the innocent here. As government, we really need to meet accessibility targets. So we're very excited because we were going to be one of the first responsive websites. We were actually going to hit a lot of the accessibility targets that were mandated. And we were using a completely open source stack. It was a lot of really big changes from this monolithic kind of Microsoft-bound enterprise to this really small team working with this new technology, and it was a very, very big deal. The most important thing is to take out of that, government mandates accessibility. We had a legislated obligation to make sure that we met a whole variety of different technical and bureaucratic requirements. We had to do a huge amount of work to meet that obligation. So back then I was working a lot with video, and most people put a video up on their page or embed a thing off YouTube or whatever, but we can't do that. We had to actually, at the time there was no standard around it, so I had to implement the latent WebVTT standard, implement the first time text tracks specification, keep that going, work with the W3 to actually get that there. That's how serious the accessibility requirement was. That's what we needed to get video on our website. That's how far we had to take it. So we went over this website with a really fine-tooth comb, measuring everything, looking at everything from the typography and the design, the markup, the quality of what was output. Everything had to be perfect to ensure that we met those targets. And at least as far as we measured, we could say with quite definite certainty that the website hit WCAG 2 AA, which is the Web Content Accessibility Guidelines. Basically a collection of targets that you can demonstrate a certain level of compliance against. And we most likely very greatly exceeded it. Problem was, the old website didn't look quite this bad, but the front-end markup had years and years of legacy. It had been imported through a whole variety of different CMS systems. It had been left to ossify. Everyone was editing it. There was no consistent standard about how that worked. The thing is, we needed all of that content. That was information that people actually had to access. And as a government department, we need to provide that to people. That's another one of our legislated obligations, to be communicating this material. So the actual process wasn't that hard. I scripted a little crawler to move all of the material out, and for most of the process it was flying along without a hitch. Had like a little Bayesian classifier to work out which DOM node contained the content, and looked at the links and the structure and everything, and that seemed to be working. But sure enough, there was bad markup and busted pages and completely inaccessible code that was steadily making its way into the website, corrupting everything that we'd worked so hard to make sure was really pure and standards compliant. And there was such a volume of it that it really felt like everything was stacking up against us, and we just couldn't manage all of the stuff that was coming in. We're a small team, and this was a huge editorial workload that we had. I mean, it wasn't really a technical problem so much as it was a organizational issue. That's how big it had become. We just had no spare hands to actually work on this problem. So management was freaking out about it. We had no visibility over how big the problem actually was. They were talking about potentially delaying the entire launch of this new website that we had to launch anyway to meet the accessibility requirement because we just couldn't know the scale of the problem. And we really didn't want to delay the launch of this thing. So what about better tools? There's got to be something out there that can solve this problem. We started investigating and doing a lot of research into what the best solution might be for that kind of thing. There's a whole suite of different accessibility testing tools out there. Unfortunately, there are some issues with these. So they don't really crawl that easily. We had thousands and thousands of documents and pages and resources of different types and formats that we needed to be able to quickly verify. So the accessibility testing tools would often sit there and we use them to actually verify the individual pages. But when you're dealing with such a massive scope of content, they weren't practical in that regard. And the other thing is we had a whole variety of custom rules. We created different constructs and things that we needed to verify were still, with the old content, working appropriately. And accessibility testing tools can't manage things, usually can't manage the things that you do yourself. So we needed to have a whole bunch of our own stuff in there. And so at least we could hit the markup, right? Well, unfortunately, because we were using Drupal, and that's a story for another day. The Drupal filters were cleaning up the markup. That sounds great at first, but when you realize what it's actually doing when it's cleaning the markup is removing the problematic attributes, yep, cool, and it's auto-balancing it. So if I had, say, a list that had not closed the list items in that list, and they were considered nested within one another, Drupal would just go and add close li, close li, close li, close li at the bottom in order to balance the markup. But it wouldn't actually fix the problem, which is that they're all inappropriately nested inside each other. And then the markup validator wouldn't be able to see the problem because it's like, well, this is valid markup. It's all balanced appropriately. It's well formed. So the problem was actually disguised by our stack, which was a really difficult situation to be in. So at the time, I was really thinking about CSS. We had to check the validity of the CSS as well. We needed to test it, and we needed to make sure that that wasn't causing, color contrast issues or whatever. And I was writing a lot of CSS as well because, I'm a web developer and I was working on the front end of this website. So CSS at the time was really on my mind. And I must have been looking at something like this when it hit me. A really simple selector. This is very elementary stuff. Everyone knows what this is doing. But in this is a kind of, it's almost a perfect example of the flexibility of CSS. Because we understand this from the context of the browser. We know that this is setting intro H1, the color of that, to red. But if you flip it around, what this actually can be is an assertion. I'm selecting intro H1, and I expect that the color is red. And when that's violated or when that doesn't meet with our expectations, then we can throw an error. We know something's wrong. The beautiful thing about it is there's no code difference between the two of them. It's exactly the same code. So that was pretty much all I needed to go, okay, well, let's write a custom test framework around CSS as a language. And the result of that was what I call behavior assertion sheets. Lest anyone accuse me of abandoning the front-end stuff for this crazy tool set work, that's a CSS-only speaker. And if you go to the website, you can check out how I did that. This is what it looks like. So this is the only wall of text you'll see in the presentation, so don't freak out too much. But it's a pure superset of CSS. It adds some extra syntax and some different abstractions on top. Some of the declarations are slightly different, but it's a pure superset of CSS. It even uses a CSS parser to work. At the core of the language, there are these things called assertions. And if anyone's familiar with testing, that's the fundamental component of testing, is assertions. In behavior assertion sheets, an assertion has a subject, which is what we're looking at here. We're looking at the status code. And then we have an expectation, what we want that to be. In this case, we want the status code to be 200. Subject is a property accessor instead of an assignment, so we're getting something out instead of putting something in. And the expectation is a really simple comparison. So the expectation could be these things that act a little bit like functions. If we were looking at transform before. We want the text to be shorter than 10 letters, and we want it to not match this regular expression. And you can put as many of those in a single declaration as you like. Then, of course, you can't have something based on CSS without the most fundamental part of CSS, which is selectors. They specify the resource that's tested. They work exactly the same way. There's no change in the selector language at all. You can use all of the CSS3 selectors that you regularly used to. There's lots of power exposed with nesting. So a lot of preprocessors, they use nesting to avoid repetition. The semantic meaning of this is a little bit different. This executes conditionally the tests against the H2 document descriptor if there's one or more H1 document titles in the document. So that gives you a lot of flexibility to do conditional testing and things like that. And then wrapping all of that up are these things called @rules. Now these are similar to media queries. The cool thing is, and I think it's CSS, it's a level 4 module. This is actually coming into CSS. I wasn't involved with that at all. Someone else just thought the same thing as me. There's a document declaration that lets you say, okay, when do I want to apply these rules? Do I want to apply these rules, in this case, on a page where the status code is 200? So I want to test successful pages. That could easily be 404 if you wanted to make sure that your 404 pages were working properly. You could check like the title of the page or the URL. All of that power is available to you. This is a node module. So if you have node already, it's as simple as going npm install bas, and it'll put in path, and then you can use it anywhere. If you don't have node, I'm working on a Chrome extension and a Firefox extension so that you can do all of this graphically, and that's going to help a lot of people, I think, because I don't really want to use Node at all. But Node's cool to learn anyway, so I recommend that you check that out. The invocation is as simple as this. You give it an assertion sheet that you've already written, and you give it a URL or list of URLs. In this case, we're crawling example.com, and we're looking at the output of that against this sheet that we have there. So this is what the output format looks like. If you've used any kind of test framework, especially like Mocha, for instance, this is going to be quite similar. And I have a video of crawling a website here. I wonder if it's playing. I think it's playing. Whoops. There we go. It's going now. So you can see it scanning the surface of the website, finding resources, checking each resource against those specific tests that were built. This is really powerful, I'm sure you can imagine, for checking a huge amount of content against business-specific requirements. So that basically, that was the goal, and I think we achieved that. And then when this finishes, I think I'm requesting about 100 resources here. You get an output of all of the information that it found in the test. You can export that to a variety of different formats. And the cool thing is you get a CSS selector that it generates to find the thing that had the violation. So you can dive in there and open that in the web inspector and go, oh, okay, there it is, exactly right there. And you can annotate each of these so that you can know from a human perspective where the problem is. Nifty thing is, anybody who knows CSS can start writing these tests. This is a very light abstraction on top of CSS. There's maybe 10 or 15 minutes worth of additional things that you need to learn in order to actually start working this way. The CSS can be easily refactored into BAS because if you've been writing styles that are decoupled from your HTML, everything's relatively general and neatly refactorable, then your assertion sheets will also benefit from that. If you've got markup that can be easily targeted, then you can easily target that with tests. So writing a good web front end makes it testable by definition. Because you've written that good web front end, everything's general. So your behavior assertion sheets tested general and reusable as well. You can take something that's designed to target one module, change it slightly, and apply it somewhere else. And if you're smart about how you write them, you can really, really reduce the actual surface area that you, or the complexity of the code that you're writing. And so you can get more than just lists of failures. You can generate really high-level statistics about this, but you don't necessarily have to write assertions about things that are wrong or errors. You can say, well, I want general information about the reading level of this material on my website. I want to know what the position information of all of the H1s are, or how far down the page they are. That's information that you can extract with this because you can just write a simple test that will pull that out. So the most fundamental part, and the part that benefited us the most, is we knew where we stood. The long and short of it is we didn't have the resources to fix a lot of these problems anyway, but we knew where they were. We could devise a strategy around solving them, and we could educate management and the people, the stakeholders involved in the project. We didn't have to delay the project, which, you know, for us in government would be not just like 2 or 3 weeks, it'd be like 6 months, a year before we could consolidate enough people to go on a working group, to get the steering committee, to get the working group, to organise your stakeholder engagement program to know that we need to do this, and then we go back to the working group and get the go-ahead, etc., etc. It goes on and on. So that was really important. That saved us a lot of time. So basically it worked. We had that visibility. I keep finding new applications for it. Recently, I was involved in my current employer refactoring a large application that was going to be sitting behind, I think it is Australia's most highly trafficked website, and one of the most highly trafficked websites in the world. We didn't want this thing to break. We were going to be deploying it into production, and absolutely all of the output markup had to be the same. So we wrote tests against the current application, found a few bugs in the current application, interestingly enough, and then applied those same tests to the refactored application. We knew and we could certify that the output formats were the same before pushing it live. And of course, we have, you know, other testing frameworks and things operating in parallel to this, but this gives us that kind of client-facing overview that we needed to be absolutely sure. So what are the applications of this? Integration testing, verifying the output from integration tests. You can plug BAS into your CI system so that you know when you've introduced a bug or broken the output somehow. Availability monitoring. You can move beyond things like, you know, if it's a 503, send me an email, blah, blah, blah. There are things that would affect the availability of an application or website beyond just, is it accessible via HTTP or not? Maybe the sign-up form is broken or something, someone's defaced the website, still returning a 200, still returning content, but it's completely inaccessible to users. In that situation, a more sophisticated test that can actually introspect a website is useful. Accessibility compliance is a big one. You can find all of the common pitfalls or poor code or stuff that's really, really nested or problematic. You can write your own specific requirements, which is really fundamental to our specific issues, but that's, I think, going to be matters for a lot of people as well. And the other thing is you can evaluate the accessibility status of your entire application or website. You don't have to just look at one page and think, oh, well, this is a representative sample. And then reporting all of that. You can aggregate all of that information, digest it down into something that's useful. and something that can be presented in a way that's not like pages and pages and pages of text. You can give people a high-level overview of, okay, well, we have 700 pages where images with our alt tags were present or something like that, or the reading level of those alt tags were too high or they were just useless information. So you can't provide a useful tool if it isn't open source, and this is all open source. You can get it on GitHub. And there's a very comprehensive reference guide to the language. It drills down into every construct and every bit of information. And it comes with a whole example file full of all of the accessibility and conformance checks that we were using. So you can go and have a look at how that actually works. And tell me if you like this or if you really hate it and you think this is a stupid idea and I should get off the stage, because I am interested to know what the alternative ways of thinking about this are. So that'd be really boring if that were all my presentation was about. My goal is not to get everybody using this, although that would be cool. The message I want to leave people with is to think about the possibilities of the tools that you're using. What can you repurpose? What might be better applied in a different way? This ties into pre-processors. There are so many great preprocessors available now. We're kind of experiencing a preprocessor renaissance. There's new technology and new build tools and all of this stuff coming out constantly. I can't turn on Twitter without seeing something like that in my timeline every day. There's never been a better time to hack CSS to do the things that you want to do. This is awesome. If you haven't heard of Rework, it's an amazing node-based framework for creating custom preprocessors and forms a wonderful platform for writing any kind of software that sits on top of CSS. I didn't use it for Bass, but if it had been around when I was writing Bass, I would have used it in a heartbeat. It has a CSS parser, it has node traversal, it has everything that you'd need in order to write something on top of CSS. And you don't have to go in really, really deep into the computer science stuff to make it work. It's quite simple to use. So I guess in the interest of exploring what's possible with CSS, I want to give everyone a challenge, and that is to make a new tool or processor or something else with CSS that might not just be about styling. Maybe it is about styling at the end, and the end result is about styling, but the way that it works isn't necessarily just in the browser making declarations about elements. So I've got kind of two ideas. Maybe they're stupid. Maybe you really, really hate them. That's okay. But these are just kind of like story starters, if you will, that you can scoff at or you can ponder. You might think they're silly. You might think they're wonderful. That's okay. I'm just going to throw them out there and give people a kind of really broad overview about the kind of things I'm thinking about that might be possible. So one of the most annoying things / contentious things about writing a web application at the moment, and there's a whole bunch of people with really strong opinions on the best way to do this, is binding data in your document to, binding data from your JavaScript side of your application to nodes in your document. And there's lots of different frameworks to do that, like Backbone and Knockout and Angular and now Polymer. Everyone's got their own opinion. But you could actually specify a lot of those relationships with a kind of mangled CSS syntax. It's perfect for those level of declarations. The way that it works, targeting a node specifically with Selector, which can be general or it can be specific, enables you to really accurately put information, apply information maybe from a JavaScript object into tie it to DOM nodes. So it might be that your JavaScript is still handling all of the information, but this is like a translation between that and the DOM level of the application itself. So there are pre-established conventions for talking to JavaScript too with CSS. So you know how the things are going to be called in one versus the other, which is nice. Or completely left field, we've got JSON. How about CSSON, CSON? So JSON has a few flaws. Like for instance here, if I wanted to describe the keys John and Jane, and they were both exactly the same, I have to specify those things twice. But with a comma, one comma in CSS, and specifying another key name, I can make those two in the one go. There's an implicit kind of semantic method for including external information, for having multiple values, different data types. For the bottom one, you could potentially create like a wildcard attribute that enables you to go, well, my object uses .anything.invalid will always return this information or has that information associated with it. So there's a lot more power that is derived from CSS that could be available to you here. The lesson is, CSS is beautiful. It has this amazing declarative syntax which can be just mutated in all these wonderful different ways. Maybe people hate that, but I think this is eye-opening, the number of potential uses that it has. It has really simple parsing. It enables all kind of introspection and processing, and I'm always thinking of new things that you could actually do with this. The fundamental lesson is reevaluate and explore the tool set that you're already using. Maybe you'll go off and you'll make something, but it won't be based on CSS. That's okay. If it's a reimagining of, I don't know, HTML or something else, maybe it's a new build chain, or maybe it's a new way of specifying modules on the client side. All you need to be doing for my talk to have succeeded is to think about new ways that you can explore what you're already using now. I don't pretend to be an expert at this. In fact, I'm just starting out. But building my own tools helped me learn most of what I know about web development today. I think that's the most important thing that I can impress upon people. It was a hugely useful learning experience. Again, you can find behavior assertion sheets at bas.cgiffard.com. Let me know if you love or hate it, whether you think it's a silly idea. Go forth and create.